It is Monday. Whether it happens. But there are few people who are very happy. Gaurav is like that. Madhi madam is like that. I am not like that. For me, Monday is a very horrible day. Professional satisfaction, how to quantify? So, saving time, we are not discussing. There are 3 items. Katrina Kaifs. So 4 items which can be quantified, which can be measured directly, right? So academic vigor, professional satisfaction, and professional growth. Say again, A1, B1, C1. These are not railway AC coach, right? These are variables. So measurable variables A1, B1, C1, and we can measure, quantify, observe A1, B1, C1, which can define professional growth. Up to here it is clear? And if you can conceptualize that this type of situation is very common in our management, very common. We cannot measure each and every attribute, each and every phenomena. So there are so many things which cannot be measured. We need to follow this route. Are you able to understand? And that's why all complex studies in management are having either factor analysis, because it is considering a latent variable, it is considering construct which cannot be measured directly, and structure equation modeling. Now, what type of, up to here, whatever you are seeing on the board, it is what? It is what? This we have discussed today before lunch. Whatever you are seeing on board or whatever we have discussed so far, it is what? Factor analysis. Factor analysis. Now, the factor analysis which you, and can you see there is a difference between the factor analysis which we have discussed in the morning and the factor analysis, if it is factor analysis, is shown on the board now. There is a difference. What is that? Huh? Huh? Very correct observation. In the morning, we were trying to know that which 3 can be clubbed, which 4 can be clubbed, or which 3 can be clubbed. This was the objective of in the morning when we were running factor analysis. Able to understand? Yes or no? Yes. Now we are doing reverse. Now we are saying academic vigor is measurable by this. We are doing reverse of factor analysis, whatever we have done in the morning. And we are saying professional growth can be measured by these 3, reverse of whatever we had done in the morning. Professional satisfaction, reverse. We are saying that A, B, C, D. Who is deciding that A, B, C, D are the real items who will define professional satisfaction? Who is deciding this? Researcher. You. If you are conducting a study, it is you. And this is very important, right? And here is a caution or an important thing. Those who are going to apply structure equation modeling. Maybe your mathematical output or statistical, now lot many p-values will come. As it is factor analysis and multiple regression, now tons and tons of p-values will come, right? So, maybe p-values or statistical analysis are against, and they may indicate that A, B, C, D is not depicting professional satisfaction. It is possible. What you will do? And before that, there is a question which will be asked in your defense or which will be asked by any reviewer. How you have decided that A, B, C, D is leading to professional satisfaction? What is your base? And there you need to say that I have studied 50 research papers on the same phenomena, and I have seen that A, B, C, D are used for defining professional satisfaction. In book, it is mentioned that your theoretical framework has to be very strong before going for application of SEM. Don't just apply for the fun sake. Otherwise, you will be in trouble. You will not be able to defend so many things because it is highly conceptual. Your conceptual understanding has to be very strong. You need to say that A, B, C, D, yes, these are leading to professional satisfaction. And just for achieving this or attaining this, you have to spend somewhere around 6-7 months probably. Whatever we have learned in the morning under the name factor analysis, precisely that is called exploratory factor analysis. What it is called? Exploratory. You are exploring, right? And in the context of structure equation modeling, it is confirmatory. It is confirmatory factor analysis, because here you are not doing any exploration. Your exploration is done conceptually, theoretically by you beforehand, and now you are just confirming it. Up to here it is clear. The way there was a concept of reliability of scale, something of that will be here also. And obviously, when you were doing exploratory factor analysis, there was an obvious issue which you had addressed, that whether your scale is having proper reliability or not, and you had taken the help of Cronbach alpha, which was required to be minimum 0.7. Here, all these three are really leading to academic vigor or not. Here, Cronbach alpha is not going to be used. Here we will call it convergent reliability. Convergent reliability. Whether all these three items, don't laugh when I am using items, all these three items are converging to academic vigor or not. So we will learn a term, convergent reliability. So today we will try to create a very fundamental base for SEM, right? And I will definitely take you to SPSS procedure so that at home you are able to build a model and see few things. But before that, some basic things are required. And whether this factor, because in factor analysis there was a mathematical procedure, scree plot, eigenvalues, communalities, loading factors, squared loading factors. So many things were there in your support that these 4 variables are leading to this factor. Here all those things are not there. Here you need to defend by your conceptual understanding. This is a very big difference. And anybody will question you that whether this factor and this factor are really different, or you are just moving in some zone which is not very much strong, or your conviction is baseless, or you are just ad hoc, or still conceptual framework is not built very properly. So many doubts will come when you present your SEM paper or SEM work. Those who know SEM or those who will review your work will have these type of things in their mind. They are not explicitly express it, but as by default the flexibility is with you, to decide whatever observed items are going to be associated or leading to a latent variable, whether you have misused the freedom or you have used this flexibility in the right way with proper homework and with proper efforts. That's why if that question is in mind, this construct and this construct is different or not different, or whether these are significantly different or same, you will use divergent reliability. What you will use? Divergent reliability. So two things are very important in the case of SEM: convergent reliability and divergent reliability. Right? After understanding this, now we are going to run our structure equation model, SEM model. And what was the basis of factor analysis? This question was asked 2-3 times and you had replied correctly. Correlation. Correlation was the basis of factor analysis. For confirmatory factor analysis, or for this part, the basis is going to be, as this is factor analysis, something like correlation should happen here, na? As it is finally factor analysis, though it is confirmatory factor analysis, there has to be something like correlation which should play its important role here. What is that? Covariance. 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 So, in SEM, covariances are the root or the base theme. Covariance between this, covariance between this, covariance between this. Are you able to create an analogy or a parallel comparison of exploratory factor analysis and a confirmatory factor analysis? There are analogies. So if you have understood that part very properly, you are going to understand this with more comfort, with more ease, because you will be able to establish some logics that why covariance or why there is something like covariance is being introduced here. This is, now structure equation modeling is having two parts. What are the two parts? Factor analysis and multiple regression analysis. Now, this we tell to explain, right, that what is SEM. SEM is having two parts, which is up to here it is correct. Now, from this point onwards, we are going to use the right terminology for both. Now we will stop using factor analysis and regression analysis. Now, from this point onwards, we are going to stop and we are going to use different terminology. And the terminology is going to be, up to here, it will be measurement model. What it will be? Measurement model. And which is nothing but only confirmatory factor analysis. But now from this point onwards, we will not use this term. As we have understood what it is, now we will say that this is measurement model. And the remaining part where you will build multiple regression or use multiple regression type of thing. Now we are not going to use the term multiple regression, we are going to use structural model. Structural model, right? So the moment it is regression, it is structural model, and before that it is measurement model. And sometimes structural model is also termed as, which is partially correct or largely correct, path analysis. Path analysis. Now, it goes without saying that you cannot straightway jump to structural model before verifying measurement model. It is ridiculous, and it is going to be something nonsensical if you have not proved that your measurement model is pakka. You have not done that, and you are describing some regression type of things. It is not making sense. And in SEM, 80% efforts are required for measurement model. 80 to 90% efforts are required to build measurement model and to get it clear, and once it is done, rest of the things are very easy, and they are only 10 to 20%. There you will just, once your measurement model is approved, you can proceed further, and you have to only explain your R square and regression weights, that's it, which is very little of the total. But before that, convergent reliability and divergent reliability, and there are so many other things, those things are really very important. So the base is done, base is clear. Now, this is very interesting. In one FDP, almost in many FDPs, probably in all FDPs, the moment we go for building model in MOs, all participants say, "Sir, ये आज दिन का शुरुआत में क्यों नहीं बताया?" It is so interesting, and it is really very interesting, very interesting. So open your file, demo file, SEM demo file, and so you need to have 3 books with you always, Business Statistics, Naval Bajpayee, and multivariate data and multivariate analysis, Black, Tethan, and this. And the example of SEM, which we are going to discuss in this, is taken by Naresh Malhotra's marketing research book. And this is again a very famous book, Marketing Research by Naresh Malhotra. And Naresh Malhotra is a very famous person. He is in America, and he teaches in America, and wonderful book and wonderful professor. Coming? What is this United Nations Security Council?
Sir, it was written by mistake, thinking that this is the board.
Okay.
We try to move it with
Okay. Good. My water bottle. Bring my water bottle. So now I will explain, and then I wish that you should be able to draw in Amos, which is going to be a very good experience if you are going to do it for the first time, and just learn how to do that. And my all PPTs are showing the commands step by step. So by looking at the PPTs at home also you can do practice. And again, it is good that in Naresh Malhotra this is only one chapter. So before applying SEM in your research, you need to understand each and every single word of this chapter from Naresh Malhotra. If you have not understood it, please don't apply. Right? Very important. And don't feel that you are alone. If you are unable to understand anything, you need to take a picture of that page and mail me and mention your query where you are stuck up, which thing is not being clear, and then I will make you clear and I will make you understand. Right? But until and unless you have absolute clarity, don't apply it, because it is difficult to defend them. You know? So this is measurement model, and this is structure model, which I have explained you theoretically, right? Now you can see 1, 2, 3 and this circle, up to here it is fine. Why these small circles, elliptical circles are coming? You are able to observe, na? That this we have, this is by 3, this is by 4, this is by again 3, then why this? And this is E1, E2, E3 and likewise, and E stands for error. Good. Now it is quite evident that this is third day. First day, just when we were discussing that this is the actual value of sales and this is the predicting value of sales, what name we should give to the difference, then we had to spend some 10 minutes, right? But now you are very easily able to conclude that if you are measuring, just for simplicity, honesty, or why honesty, academic vigor on the basis of these three. Now I assume, and you also start assuming, you are a thorough researcher. Very easily you will be convinced that in this type of setup we are not measuring humidity or temperature or weight. We are measuring something complex, academic vigor, right? And this cannot be measured with 100% accuracy, just not possible. Hence, with every item, there will be some associated error. Obvious, right? So that's why automatically there is 111 error. Up to here it is clear? Say yes or no.
Yes.
The arrows in SEM are very dicey and complicated. Probably you need to read and understand 3-4 times Naresh Malhotra's book, right? Where it is explained that which independent and dependent, how the relationship is explained. If arrow is leading towards PU1, or if this is leading to this, how you will interpret this depends on this or this depends on this?
Factor depends on item.
Ha, sir?
Factor depends on item.
This depends on item. I was also thinking like that. But actually it is reversed. Your number of conferences or number of research papers depend upon academic vigor. Are you able to understand? Your number of whatever it is, or your education qualification depend upon your academic vigor. If you are D.Lit, it shows about your academic vigor. Are you able to understand? So, this depends on this, and similarly this depends on this. The conventional way of understanding is different. If arrow is leading towards, then we interpret that this depends on this. No, reverse. Just refer Naresh Malhotra's book and build a very good clarity about direction of arrows and what it says. Refer book. And this circle is what? This arrow is what? With 2 arrows is covariance. This will show covariance, right? And so everywhere there is this, and 1, 1, 1. By default it will come. Whatever number is written here, or here, or here, whatever number. What is this number? You can, if you are intelligent enough, you should be able to tell. What is this number? If there is some number here, what it is? And I am telling you, this depends on this. What is this number? Quick.
X variable, Y variable. X is the
Regression coefficient. Very correct. Regression coefficient. Now we should be able to understand the moment somebody is saying A depends on B. If there is dependence, there has to be a regression coefficient. Simple. Now we are not beginners. This is third day, 4:30 p.m. 4:45 p.m. right? And things are very easy now, right? It should be crystal clear in front of our eyes. The moment it is a dependent relationship, there has to be a regression coefficient. That's it, so simple. 1, 1, 1, 1. Already Amos or SPSS had assigned 1, 1, 1. Amos is trying to save your headache. Otherwise, you are supposed to calculate regression coefficients. And it is very difficult to calculate regression coefficient between error term and a measurable item or variable. Difficult. For making your model easy, workable, Amos had already assigned regression coefficient as 1, 1, 1, and 1, 2, 3, 3 relationships are shown here, just in order to create a sync or a standardization type of thing. Out of these 3, 1 is made 1, so that rest will follow accordingly. Intelligently it has automatically placed 1. Up to here it is understood? Say yes or no. We will make this model through, and then this is your structure model.
Sir, repeat it, sir, last what you said. Just now what you said.
Out of 3 arrows, out of this assigned 1.
How you said, sir?
What again please?
Out of 3 arrows,
Ha,
1 arrow has been assigned with regression coefficient 1.
ha.
So what about other 2?
These are going to be estimated by your model. One is set, one is freezed. One is freezed, set. And the remaining here and here, these regression coefficients are to be calculated by your model.
Is 1 the hypothetical value that?
Exactly correct. A 1 is a hypothetical value, and there were statisticians or there were thoughts that they should give 10 or they should give 100. They had done many experimentations and they have decided that 1 is good. If they assign 1, it serves the purpose. Clear? Say yes or no. Sir, no problem. Phrase your doubt again.
Repeat it, sir. That's what I'm not getting. Do you say the way you are saying intercept or beta, this way you are saying alpha, beta?
Intercept. I have not used word intercept so far. And today I think that before lunch, after lunch, before tea, after tea, I have not used the use the word intercept today. Don't worry, don't hesitate. Express your thought. See, this whatever was on board is clear to you now. The same is here with some other terminology. Same thing is here. Only here I have not shown error term, but I have taken your consent and you agree that if you measure this for defining this, there will be some error because it cannot be exact. Same error terms are there. Up to here it is clear. Then whenever there are arrows like this, single arrow, it shows a dependence relationship. And if there is a dependence relationship, there has to be a regression coefficient. If there has to be a regression coefficient, you need to calculate it. You means your big brother SPSS will calculate, right? And making models synchronized and making your work easy, few are already decided 1, 1, 1, because you know, I know that we cannot find this regression